So I'm going to go through some of the lessons that you would have been taught from chapter 1 of the year 2 Pure book to help you with your home learning, and that's all about rational functions. If you have any questions, or if you don't understand anything, or if you try some questions from the textbook and they don't make sense, then you can leave a comment, or you can ask a question on Show My Homework. Try not to email us, because we're not going to be checking the emails regularly, because there'll be too many of them. So I'm actually going to start with the work for exercise 1B and 1C. 1A is kind of a standalone section of chapter 1 about proof, and I think you'll find that a little bit harder than the other parts of this work, so I'm going to leave that one till a little bit later on in the sequence of lessons. So we're going to start off with fairly straightforward adding and subtracting and simplifying algebraic fractions, multiplying and dividing them as well. So an algebraic fraction and a rational function are the same thing. They're just fractions where we've got polynomials in the numerator and the denominator. So these are two examples of algebraic fractions or rational functions. And we have seen these type of questions at GCSE, so this should all be revision. Exercise 1B and 1C should all be revision, just maybe a little bit harder or requiring a few more steps than we would have needed at GCSE. So as I've just mentioned, we need to be able to simplify them, multiply and divide with them, and add and subtract, and that's all covered in exercise 1B and 1C, as I've already mentioned. So I'm going to start off with simplifying, and the trick with simplifying is to, as with any fraction, cancel down any common factors in the numerator and in the denominator. I've got 3 questions here for you to have a go at. You might want to pause the video and try them on your own first, and then see how I work through them. If you're not sure, you can just obviously watch the video and then try some of the questions from the textbook. So if you've had a go, then I will answer question A. In order to simplify question A, I'm going to take out a common factor of x minus 3 so that it can be cancelled. There's obviously no factor to be taken out on the top, but on the bottom I can take out a factor of 4 to leave me with x minus 3 there. So they will then cancel. Remember, you can cancel when things are being multiplied, but you couldn't cancel when things are being added or subtracted. So I couldn't cancel the 3 and the 12 by 3 because there's an add here, not or a takeaway, not a times. So that is fairly straightforward. That's just a quarter. Number 2, there's a bit of a clue as to what to do. Again, there's no factorisation required on the top row, but that does suggest that on the bottom row there's going to be a factor of 2x minus 3. So that will help me factorise the bottom. I'm going to assume that the x terms are 3x and 2x, otherwise nothing would cancel. I need to find 2 numbers that times to make 12. So that's going to be 6 and 2 or 3 and 4. Now, when factorising, you can do a few extra little bits and pieces to help you reduce the options for factorising. Because this is an odd number here, I've got -1 here. I know that 2 and 6 will not work as factors. The reason 2 and 6 won't work as factors is because when they get multiplied out, that's going to give me an even number of x's, because I'm timesing by 2 different even numbers. That's always going to produce an even number. So it can't be 2 and 6. No matter which way round I put them, it can't be 2 and 6, which means it needs to be 3 and 4. 3 and 4 is good because I also know that the 3 can't go here. And the reason I know the 3 can't go here is because if it did go there, I'd be able to take that out as a factor. And there is no factor of 3 common in all three of the terms here, which means the 3 can't go in this bracket, it must go here. So the 3's got to go there, which means the 4 has to go there. Similarly, the 4 wouldn't be able to go here because that would give me a factor of 2, which not all these terms have either. So the last thing to then decide is the signs. I need to make a negative x. Here I've got 12 x's. No, I've not. I've got 8 x's and I've got 9 x's here. And I need that to overall become negative x, which means I'm going to need to do positive 8x, take away 9x. So that's the correct factorisation. We could have used the top to help us to know that it was going to be a 2x minus 3, but it is always good to practice your factorising. We kind of get a bit rusty at that after GCSE because we rely on the calculator so much, but it is good to practice that. Finally, we can cancel these common terms and be left with 1 over 3x plus 4. For the final example, we are going to have to factorise both. I'm going to start with the top. It's got to be a 3x and an x. The fact that we've got a 4 here means it's either going to be a 2 and a 2 or a 4 and a 1, and we don't know which way around that's going to go. Because it's quicker to check the 2 and the 2, I'm going to hope that that's right, and if it's not, I'm going to have to go and try the 4 and the 1. But just to hopefully save a little bit of time, I'm going to try this one first. They've both got to be negative. To make minus 8x and positive 4, that would give me minus 2x's and minus 6x's, so that would collect together to give me minus 8x's. So I was right to try the 2 and the 2 first. That doesn't massively help us with the bottom, because it could be a 6x and a 1x, or it could be a 3x and a 2x. They've both got the 3x and the 1x terms up here. I'm going to take a punt at 3x minus 2, and if that's 3x minus 2, this would be 2x minus 1. To make positive 2 and hopefully minus 7. Let's see if that works. That's minus 4, yeah, and minus 3, which would give me minus 7. So that's right as well. So that's the correct factorisation on the bottom. That then leaves us just needing to cancel down the common factors, and this time the final answer is x minus 2 over 2x minus 1. Okay, so that's a few examples of simplifying algebraic fractions. I'm going to move on now to multiplying and dividing algebraic fractions. Now, a really common mistake is to actually do the multiplication and expand brackets. Try not to expand any brackets, because if you expand brackets, you're going to just end up with harder things to factorise, and we're only ever going to be able to cancel things down by factorising. So there's no point in expanding first. We may as well just factorise everything that we can see as much as possible and then bring the two fractions together. So I'll give you a chance to factorise and cancel down both of these, and then I will go ahead and work through them. Okay, so hopefully you've had a chance to work through these two examples. As I said before I left you to it, we're going to factorise everything as much as we can. So the top left is going to factorise to, what's it going to be? We need a 3 and a 2, a plus 3 and a minus 2. The bottom is going to be x plus 3 and x plus 1. And on this side we're going to have, let me just bring that down underneath so I've got more space. X bracket x plus 1 and the bottom is going to be x and x, and it's going to be, we need a 4 and a 2, positive 4 and negative 2. You could write all these now together, bracket by bracket by bracket, or we can just cross cancel wherever possible. So the x plus 3s are going to cancel. I've got an x minus 2 on the top and an x minus 2 on the bottom. I've got an x plus 1 on the top and an x plus 1 on the bottom, and so that is just going to leave us with x over x plus 4. Okay, for number 2, part B, it's a divide question. Now, if you remember, when we divide fractions, we flip the second fraction over and times instead. So I'm just going to rewrite that as a multiplication question. Sorry, x minus 2 there. 2x squared minus 7x plus 3 over x. Again, factorise everything that you can see. This is going to factorise to x minus 3 and x minus 1. This is going to be 2x and x, and I need to make 7, so I'm going to want the 3 over here to make 6, and then 1 more makes 7, and then we can go ahead and cancel whatever we can see. So I've got an x minus 3 and an x minus 3, and I think that's it here. So that's going to leave us with x minus 2, 2x minus 1 over x bracket x minus 1. Now, I can absolutely guarantee that nothing else cancels down. That's the good thing about factorising first. You don't need to expand and refactorise. There is definitely nothing else to cancel. Now, I've actually got a third example here that you can have a go at, another divide question, but with a little bit of a twist. I've got a negative quadratic here, which they do sometimes do, so you need to just be a little bit more careful with this term. And there's a few different ways to factorise this, but again, I'll leave you to have a go first. Okay, so if you've had a go at this one, we can do, as I said, we can do a few different things. What I'm going to do is, because this is the only negative quadratic, I'm going to actually take out a negative 1 factor. Because then everything else will match. And it will be easier to spot the common factors. I'm also going to need to times by the reciprocal of this fraction. Okay, so I'm going to factorise the top. I've got a 2x and an x. Again, I can use the fact that this is an odd number to tell me that I can't have a 2 and a 2 here. It's going to have to be the 4 and the 1. The 4 can't go here, otherwise there would be a common factor of 2 throughout. So the 4 has to go there, 1 has to go there. And in order to make positive 7x, I'm going to need a plus 4 and a minus 1. Times by x minus 1 over, I'm going to guess again the 3x and the 2x. I might end up being wrong, but that's the risk. It's a 2 on the end, so it's a 2 and a 1. 2 can't go here, has to go here. And that would make 4, 5, 6, 7. Yep, so that's right. Cancel anything that is in common, and it's easy to spot the cancelling now because we've taken that minus 1 factor out, and there are the only factors we can cancel. These do not cancel, okay? So we are left with minus x plus 4, x minus 1 over x minus 4, 3x minus 2. So the last thing we need to be able to do in this section for exercise 1b and 1c is adding rational functions or subtracting, and we treat these exactly the same way as we would treat numerical fractions. Just we find a common denominator and we add in the same denominator. So common denominator on these two, they have nothing in common already, so the common denominator will be just the product of them. So I'm going to multiply the left-hand bracket by the the left-hand fraction by the right-hand denominator. Remembering it's a minus, that's a common mistake to not subtract. And I'm going to times the right-hand fraction by the left-hand denominator. Exactly the same way as you would in numerical fractions. We can then bring this under one fraction. Now I like to do this step first because it will help you avoid a mistake with this negative sign. If you expand these brackets, people often then forget to write minus 12 when they've brought the two terms together, and that's obviously wrong. So this avoids that mistake. I'm just going to move that out of the way. Oops. And then we can add the fraction or subtract the top. That's going to be 6x, take 3, take 6x, take 12 over x plus 2, 2x minus 1. 6x's cancel and we're left with negative 9 over x plus 2, 2x minus 1. Okay, for part B, I'll give you a second to do that if you've not done it already. Just move this out of the way. For part B, in order to get a common denominator here, I'm going to write this first as over 1. Then I can times the top and bottom of this fraction by x plus 1. I don't need to do anything to the right term. And now they're ready to add. Again, bring the brackets together, the numerators together first to avoid any problems with negatives, not that there is any here. It's just good practice to do that. That will give me x squared plus x plus 1 over x plus 1. This doesn't factorise. X squared plus 2x plus 1 would factorise, but x squared plus x plus 1 doesn't factorise, which means they won't cancel. It is always good to check if this numerator factorises in case it ends up having a common denominator with the bottom. Okay, so always as a final last step, you should try and factorise the top. The bottom will always already be factorised because there's no reason to expand it. But you should check if the top factorises in case there's anything to cancel. So I'll give you a second to have a look at part C now, and then we'll go ahead and work that one out too. Okay, so for part C, you'll notice that the bottom on the left-hand fraction is a quadratic. That will factorise, and I'm guessing that it will have a common x plus 2 factor. That's going to make things much, much easier when we come to bring the fractions together. We're going to need a 2 and a 1. The 2 is going to have to go there, otherwise they'd have a common factor of 2 throughout. And it's going to be a positive 2 and a negative 1 to give me 4x, take away 1x, positive 3x. And I was right, there is an x plus 2 factor hiding in there. and I'll show you why that makes this such an easier question than you might have found yourself working through. The reason this is much easier now is because on this right hand fraction I only have to times top and bottom by 2x minus 1, and I don't have to do anything to the left hand side. The left hand side is ready to be added to the right once the right has that same denominator. So I'm going to times the numerator by 2x minus 1 and the denominator by 2x minus 1. And then we can bring them together. 31x minus 8 minus 14 bracket 2x minus 1 over 2x minus 1 x plus 2. Multiply out the top is going to give me 31x minus 8 minus 28x plus 14 the numerator will cancel to 3x and minus plus 6 over 2x minus 1 x plus 2. And this is what I was talking about on the previous example. This factorises, it's got a common factor of 3, so I can take that 3 out, and that's then going to have a common factor with the denominator of the x plus 2 term. Those x plus 2 terms can cancel, so the final answer on this question is actually 3 over 2x minus 1. Okay, so I think that's my last example. You should now be able to work through exercise 1b and 1c of the Edexcel textbook. There's loads and loads of practice examples in there. I've tried to cover as many of the different types of questions that you might come up against from those exercises. But as I said earlier, if you've got any problems, drop me a comment or tell your teacher on Show My Homework, and they should hopefully be able to help you.